Now, if I give you an equation, how many possible numbers, off the top of your head, how many possible numbers could work in that equation? It could be infinity, right? First time you look at an equation, you can say, okay, anything could work, right? That's a lot of numbers to try. Now we're going to simplify it down and say how many numbers work. And that's what this rule does. It takes all the numbers in the world and says, okay, these are all the numbers in the world. Of all those numbers, rational numbers. Rational means anything that can be written as a fraction or an integer. Of all those numbers in the world, these are the only ones that you have to worry about because these are the only possible ones that work. Okay? So what we do is we go from infinity, like Jesse's saying, down to maybe 10 numbers to try. Okay? Which is a lot better than having infinity. Okay? Now we go back to Jamie's question. What happens if none of those work? We hope. We hope one of them works. So, it says, if it does, and then when she didn't ask that exact question, but what she asked was, what happens if there's no remainder? Or it's a remainder. So let's look at this equation. I'm just going to actually write it down. I'm going to have here, let's say x to the third minus 3x squared minus 4x plus 12. Now what that rational root theorem says is this. Really, the last number is p, and the number in front of your first term is q. So look here real quick. Okay, that's what it says. Okay? And what I want you to do off to the side is this. Write me factors of 12 now. 1 in 12. 2 in 6, 3 in 4. Done? -1, -12. And I'm going to save you some hassle. Your college algebra class, I'm going to save you a hassle on this one. Okay? Write me down the factors of Q. Real tough. What is it? 1 and 1. Okay? Have you got it? Real good? Go with that? Now what I want you to do is take P over Q and write me down every single number that comes out. In other words, let's start with this one. 1 over 1 is 1. So we're going to put it in here, but I'm going to save you some time. It's always plus and minus. Because like Carter said, you would have negative factors here. Right? To save you some time, it's just going to put plus and minus. Okay? 1 over 1, 1 over 1. Okay, let's go here. 12 over 1 is plus or minus 12, correct? 12 over 1 again. Okay. 2 over 1, 2, plus or minus 2. 6 over 1, plus or minus 6. 3, and the last one is plus or minus 4. What the rational root theorem says is this. If I take the factors of my constant term over my factors of my reduced coefficient, over Q. And these are the only numbers that you can plug into that equation and they'll come out with a remainder of 0. These are only possible numbers. It doesn't mean everyone's going to work, but these are the only possible numbers that will work. Of all the numbers in the world.
Is this what?
Now, wait one second. Repeat that. Only numbers in the world that are rational. Okay. Now, what I mean by that is this. Does this count square roots? No. Square roots are irrational. Okay. Okay. So square roots is a different story. These are just the rational ones. Okay. Now, how do we know which one works? Synthetic division. What should the remainder work be? How many do we have to do? This is my trick. I mean, we want to find 3 answers, right? You know how to solve a quadratic down, right? So if I find one of them work, then what am I down to?
2 answers.
I'm down to an x squared equation, right? Understand? Because remember, you always go one step lower once the answer, right? If I find one works, I'm down to x squared. Then it's a quadratic equation, right? I don't keep trying numbers, okay? That makes sense. On x to the 6, you might have to find 3 before you get down to x squared. Okay? So what number do you try? Well, if I was setting up a synthetic division on this one, I'm going to put my equation out first. 1, -3, -4, 12, and I'm going to try another. Well, I'm going to try 3. Why? I'm guessing.
No, you already know it's
What? Might work, might not. Want to try something different?
No.
Carter says try 1. Okay. Or Mold also says try 1. Okay, let's try 1.
Bring it down.
Bring 1 down.
Okay, we're going to bring 1 down, and we got 1 times 1 is?
2, 1.
1, last time I checked. Negative 2. 1 times a negative 2?
Negative 2.
Negative 2, which makes a
Negative 6.
negative 6. 1 times a negative 6 is?
Negative 6.
Negative 6, which is 6. Did it work?
No.
1
What were we
doesn't work.
trying to do?
Bet 3 words.
Once we find that this remainder is 0, then we know it works.
I don't. Oh.
Try 3.
So, Carter says try 3.
Why do you get,
But also say
why do you get negative
1 times
2
1
under
is
4?
2.
Negative 4.
How do I get negative 1 and a negative 3? I'm adding them together.
Why do you get, why do you put negative 2 under the negative 4?
Okay, let's try 3 and I'll show you. Okay, what we do here is this. First thing we do is bring the 1 down. Then we take 3 times 1 is 3 and we put it up here. Okay, then we add them together. Negative 3 plus 3 is 0. Now we take 3 times 0, put it up here, add them together, which is negative 4. Then we take 3 times a negative 4, which is a
Negative 12.
add them together, which is
Okay, you know a trick. Can you tell us?
no. I factored that in my head. That's what I did. That's what I did.
I can't do that.
So,
No, better.
no, there isn't actually. This
I bet
you have an
it's
advantage here. Okay, this kind of tells you.
Wish I could do
Okay, everybody follow me so far, right?
Yeah.
This kind of tells you how math has changed. Okay? This is a rule, it's rational root theorem in synthetic division and stuff, is a state requirement to cover in state in 11th grade or 10th grade, actually 10th grade. Okay? 20 years ago when I was going to high school and college, we didn't cover this for junior year in college.
Yeah.
We didn't cover actually trig, we didn't cover most of the stuff until I got to college. Now they're talking about moving it down further.
Like,
So that's from math teachers. This is a lot from business world saying, if we're gonna stay up with China or Japan and not have them take our jobs, we need our students educated. Because why are they shipping most of our jobs overseas? Because it's cheaper. They do it right. You know, so now let's go down here. Question, how many roots did we find so far? We found 1, right?
Yeah.
Started with x to the 3rd.
would it work for minus 3 too?
Nope.
What's plus
Because now watch this, we write x to the 3rd. Now we're down to x to the
Second.
2nd. So this equation really is x to the 2nd plus 0x minus 4 equals 0. Correct?
Correct.
Now can I solve that down pretty easily?
Yeah.
Add 4. So I get x squared equals 4. Take the square root. X is equal to
4.
plus or minus 2. You could do different squares too.
So we can do anything like that we've learned so far that solves down for x when we get to here?
Yeah.
So we
You
can,
can
like,
do anything you want.
factor,
Factor, quadratic form, and complete square. Once you get down to x squared.
How do you take out? How do you know which one to take out
How do you know which one to take out? What do you mean?
of those 4? Why did you take out negative 4?
Why did I take out a negative 4? I just worked out here. I just solved the equation.
Oh, okay.
So now look at the answers. And this is what I want you to notice of this rational root theorem. Look at the answers. The answers were 3, positive 2, and negative 2, right?
Yep.
Were they in our list?
Yeah.
There's a lot of numbers that didn't work.
How come it's not a plus or minus 3?
Didn't I put it up there?
No, like over there.
Oh, what it means plus or minus on that list means either plus 3 or minus 3 or both. It could be both.
Oh.
But it
Is
doesn't
it
mean it
both?
has to. What?
Is it both?
Is it both?
But
So
then how do you know to plug in a positive 3 up there?
How did I know to plug and play? I guess.
could we have plugged
This is a
in
guess
two-
and check method.
I don't like it.
Would 2 have
Did
worked?
you say factor in your head?
I factored in my head. But I mean, you're not going to factor most. This one's factoring in head by grouping. So
So I can factor in my head.
I'm gonna show you some tricks that what to look for too. So
Could we have plugged in 2? Would that have worked?
if you can plug in 2, it'll work. Yes. You can plug in a negative 2, and it will work.
Wait, so if we would have plugged in 2, wouldn't we have gotten out plus or minus 3?
No.
If we would have plugged in 2 here first,
Yeah.
then you would have had a different answer here. But the 2 answers that would have came out of this one would have been 3 and a negative 2.
Whoa.
It's gonna be a little different setup,
Who
but
made up math?
so
We're really smart.
let's try. This one's good. Let's try this one.
Okay.
Because I can't factor this one like that. So we'll do it. I have no clue.
I remember this one.
It's kind of fun, actually.
So we don't worry at all about the middle 2?
Nope. So what I'm gonna do here is this is my P. This is my Q. Okay. And we're gonna write down our factors of P. There was not a lot of them. Factors of P are gonna be 1 and 3. Not a lot. Factors of Q. 1 and 6 and 2 and 3. So then we're going to write down our factors of P over Q. So let's start with the ones first. Okay, 1 over 1, which is plus or minus 1. 1 over 6, plus or minus 1, 6. 1 over 2, and 1 over 3. Okay, I follow me so far? Now, what?
How do you go when you just take the x of the first ones?
Then just do it over this one, then you do this one over all of them. So now you keep going. 3 over 1 is? Plus or minus 3. 3 over 6 is?
1/2 already got us, don't write it again.
Plus or minus 1/2, actually. 3 over 6 is 1/2. We have it, we don't write it again. 3 over 2, 3/2. And 3 over 3,
1 already has it.
1 we have. So of all the numbers that could work, can't rational.
Try 1.
So we tried some different numbers.
No.
Try
What?
1.
3, because don't you want the first one?
1/3.
So now you guess.
1/3.
1/3. You want to try 1/3?
Yeah, let's try 1.
Okay, we'll try 1/3.
That's
Okay, he's saying 1/3 here. I don't remember the equation.
6, negative 19, 2.
6, negative 19, 2, and positive 3. Okay.
Draw your line.
How do you get those 4 numbers?
How did I get those 4 numbers? They're just the 4 numbers in front of my equation. 6,
Oh, okay.
19, 2, and 3. Okay, am I following? Okay, now the first step is real tough.
Bring.
Some people get that wrong.
Oh,
So, 6 down. 1/3 of 6.
2.
2, put it up here. Add them together, we get a negative.
This ain't gonna work.
1/3 is 17.
Just stop. It ain't gonna work.
17 over 30.
17 over 3.
2.
Add them, and 17 over 3 is
Negative 17.
negative 17 over 3. That's even better. Negative 4. That's 5 and 2/3. Oh, actually, that's not even 4. 5 and 2/3. Negative 3 and 2/3. And if I times that out, I'm going to get negative 11 ninths.
Okay,
Positive, yeah, negative 11 ninths.
Doesn't work.
And I don't care, that's not going to be 0, is it?
No.
So, not a good choice.
It's bad. I have a feeling in this section I'm going to go through a lot of erasers.
No. I am going to try something very close to yours.
3. 1/3. No, negative? Wait, what?
3.5.
Let's try negative 3. 1/3.
So we actually have like 20 options.
Yes, we do.
Good job.
No, the reason I said that is this. If I bring down the 6, it doesn't look much different now, but negative 1/3 times 6 is negative 2, which makes it negative 21.
That changes. Everything just changed.
So a
I
negative
knew that one
21,
was funny.
7.
negative 21 and a negative 1/3 is 7. Bring it down is 9.
Just got
Dang.
You got negative
He's
3.
got
He
And,
knows, he knows a
minus
trick.
zero.
He knows a trick.
Oh.
No, actually, I just saw. I saw that it worked out a little bit off.
I know the trick. I saw 1/3
all I saw were numbers on my brain that I'm like.
Okay.
It's shaking his finger.
Hey, hey, look at me.
Now, factoring this down, we started with x to the third, right?
Yeah.
So this comes down to x to the second minus 21x plus 9 equals 0.
God tried 3.
I think it's the 3 in common.
Yeah.
So we divide by 3, so I'm just going to say 2x squared minus 7x plus 3 equals 0. Now, if I factor this out, I'm going to have 2x and x, right? And I need a negative 7, so let's go with negative 3 and a negative 1. Now over here we get x, set equal, each one of these equal to 0, x equals 3,
And,
x equals 1/2.
Wait, why
2x minus 1
Oh,
equals 0. Anybody have 3 answers?
Yep.
Wait.
Oh, dude. 3.5. Negative
Oh,
1/3.
isn't it multiplicity of 3?
So we could have used one.
Because you factor out 3.
That 3 is gone.
We could use three.
If it's x to the third, you're going to have 3 answers.
It's
Okay, now I want to show you a little thing.
Chewing, right?
Now, here. Now, this is a little trick to look for. First thing I tried on this number, we tried 1/3. We'll come back to that. I tried a negative 1/3, right?
Yeah.
It worked. But the other thing I want you to notice is the last terms here. You'll notice that but my answer went like this, correct? 6, negative 21, 9, right? Now this is going to sound like a weird one. I don't know if the book covers this or not, but look at it this way. It goes from positive to negative to positive, right? And 0 could be positive or negative. So it went positive, negative, right? Now here's the rule. If I try a negative number, and it doesn't matter if it works or not, but my numbers on my answer go positive, negative, okay? There is no number smaller than that that's going to work.
What do you mean?
So in other words, I tried the negative 1/3, right? And it went positive, negative,
Oh, so then you look up on there.
So like the,
So-
1/6 won't work.
Yeah, then like negative 3 won't work. Negative 1 wouldn't work. So there is no other number smaller than that that's going to work.
Actually,
I don't get it.
Okay, I tried a negative 1/3.
Yes.
It went positive, negative, right? So if I go to my list of numbers here, here's the negative 1/3, right? Negative 1/2 is smaller than that, right? I know that's not going to work because it went positive, negative.
You
Neg-
want to go positive, negative, positive?
If it does that, it tells me any of the numbers less than that is not going to work. So it limits my choices.
wait, so if
So
it's
then
less
if
than
it-
that, then
Highest negative number.
So then if it does, then
it's the opposite. It's the
it's not big.
Okay, what do you mean it does?
Like,
If it works.
If it-
What are you trying to say? Well, this is what I'm trying to say.
like if
The
it's,
number that's lower than it's opposite is
if it's
worse.
negative, what if it's negative, positive, negative?
That's the same thing. It's just alternating. That's all I have to worry
So
about.
then it'd be no number higher.
No, it's still just less than. It's always less
Oh,
than.
it's always less.
Yeah. If I try a negative number, okay? Now if I try a positive number right here, okay? If I try a positive number right here, okay? And all my answers down here end up being positive, there is no number bigger than that. That's going to work.
Is it all the numbers are positive?
Yep, all the numbers are positive down there. So if I try a positive number and it all ends up being positive, I don't care if it works or not, there is not another number that's going to work higher than that.
What does it all do?
You won't, because it works. So it works. Then you won't have an equation at the end of all those. But here's a thought now. So like on this equation I have, let's say the last equation, right here. Okay, I have a lot of numbers. We tried 3, right? And I went over here and I said, I tried 3. It doesn't always work on here, but it went positive, it could be negative, positive, that didn't alternate, right? But if I would have tried, let's say I tried 4 in here, and my numbers were all positive right here, okay? Do I have to try 6?
No.
Do I have to try 12?
No.
No, it just limits your choices down, that saves you some time. Like some of you said before, well, I got 20 things to try. Well, yeah, but if I can limit the choice, there's a lot of ways to limit choices. That, discarding rules of signs, all this kind of stuff we're going to be talking about as we go through here. There's a lot of rules in this section about looking at the over cube. Some of you have dealt with all these rules before, and it's just going to review it. Some of you haven't seen these before, so. So we're doing easy ones right now. We got X to the third. Those are easy. Those are. Let's go up a level. Let's go X to the fourth.
So will it still be Q?
P over Q, first term, last term. Let's go up a level. We're going to go X to the fourth. So the equation right now, I'm just going to write it over here, is 1x to the fourth, negative 1x cubed, 7x squared, negative 9x, minus 18. That's my equation. Now I have to do my P over Q's. So if I did my P's, 18, again, I just look at the number. I mean, I go 1 and 18, 2 and 9, 3 and 6. I think
Do
that's
we
what.
not care about the negative?
Really, you're going to do plus and minus in all your factors, so it really doesn't matter. The 1 is easy. It's nice and 1, 1, right? When your P is, if your Q is 1, you just have to worry about your P. So my answers, the numbers I'm going to try are plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, plus or minus 9, plus or minus 18.
Plus or minus 1
1 over 1 plus 118 over 1 all of, right? So how many numbers? You got about 3, 6, 12 numbers we can look at, right? Now here's the thing. Our first one was x to the fourth, right? Deal. We need 4 answers, right? All the methods like factoring, quadratic formula only work at x to the second, correct? So we have to find 2 numbers to work first.
2 numbers?
Because we have to get down to x to the second.
3.
So let's start with the number that you think might work. Truman says 3. Okay, let's try it. So I tried 3. 1, 3 times 1 is 3, which is 2, which makes 6. 13, right? 39, 30, 90, and Truman's not a good pick. Can it work?
Yeah.
No. It's sort of synthetic work. Okay. All positive.
So nothing higher.
Nothing higher than 3.
Negative.
Negative 3.
So let's just go in here. I'm going to make my eraser smaller. So that's going to get rid of positive 18, positive 9, positive 6, positive 3. We just got rid of 4 numbers in that one choice.
Let's try negative.
So you want to try negative 3?
Yeah.
Okay.
Negative 1.
Actually, I have to erase first.
That's pretty close.
Negative 3. 1. Negative 3 is negative 4. 12. Right?
Yeah.
19. Oh. Negative 57.
Sorry, guys.
Negative 66. Positive 1. 98. We're not good, yeah.
What goes negative,
2.
negative?
Do number 2.
Plus 1. 80.
It goes
But it
negative,
goes-
positive, negative, positive.
Now what's that mean?
Okay, negative, positive, positive, negative, positive, negative. Nothing smaller than a negative 3.
Well, that's the only.
So that gives
Oh,
you
that gives us all those.
696.
Okay, so we got positive 1.
So negative 3 didn't work.
Oh, I said a negative.
And nothing smaller than that.
Sweet.
It's kind of funny.
Negative 1.
So we got rid of a lot of numbers in those 2 choices, right?
Negative 1. Got
Didn't
it.
try them, but we got rid of some numbers, right?
Yep.
So now we're down to only 4 choices left, which makes the problem a little nicer to work with.
There's 5.
But why
It can't be
two?
less than -3.
Can't be less than -3.
Oh,
More than.
well, you know, those 4 are your.
But no, we don't. We know that probably 2 of them are going to win. You could have imaginary, we could have rational.
Oh, so I'll use it.
Number 2.
Okay, he wants to do number 2. Okay.
Number 2, my lord, number 2.
Okay, bring it down. Now, everybody listen, bring it down here. We got 1, 2, 2 times 1 is 2, 1, 2 is 9, right? 18, which is a 9, right?
Sweet.
And 18, which is 0.
I told you guys all along.
Okay? 2 works, right? We found one answer. Now, I don't go back to the beginning of the problem again. I start with this one because now I'm down to x to the 3rd, correct?
Yeah.
Now I'm just going to start with this answer. Not worry about the 0.
Oh my god.
Now, here's the deal. Somebody says, well, 2 works, now I have to try some other number. Not necessarily. That same number could work again. It could have a multiplicity. I don't know if it does or not. I'm going to try a different number. I don't like trying the first number again. It could work again. So we just start from the answer. I'm going to try 1. Okay, Logan says a -1. Here's again. Okay, -1. If you try the -1, bring it down 1.
Will you try negative on those?
0, 0, 9, -9 is 0. Did it work?
Sweet, Logan's good at guessing.
So how many answers do we have so far?
2.
We know that 2 is the answer and a -1. Now we started with x to
Now
the,
let's keep going.
we got x to the 4th, right?
Yeah.
We have x to the 3rd. Now we're down to x to the 2nd. Now I don't want to keep going because I have x to the 2nd plus 9, right?
Yeah.
I'm going to set that equal to 0. I'm going to subtract 9. X squared is equal to a -9, right?
It's gonna be imaginary.
So x is equal to plus or minus
Oh, ew.
3i.
So this is an unreal function.
No, it's not a real function, but
just that.
that's my 4 answers.
That's the gross.
So why don't we pick another number?
So your
Okay.
answers are.
No. Shh. Sorry. We got one answer to work, right?
Yeah.
But we're still down at x to the 3rd. We can't use any of our factoring methods or anything at x to the 3rd. So we have to find one more number to work so we can get down to x to the squared. That's why we picked the number.
So your answer is.
We want to get down to x squared, the best case. Okay?
How is that not x to the square now?
Because this number is x to the 4th, we started with,
Yeah.
right? Once we find one number that works, it only goes down 1 level. So really right here, we're at x to the 3rd still. And when we find another number that works, then we're down to x to the 2nd.
Oh.
Every time we find a number that works, it just takes us down 1 level.
Okay.
Okay,
So your answers are.
my answers on here are 2,
-1,
-1,
3i,
plus or minus 3i. How many answers is that?
4.
4 answers.
So we had 4.
Imaginary answers occur in pairs, plus or minus 3i.
We put
So did we know we were
X
gonna have
equals
4
that,
answers?
Oh, I always pick the highest exponent tells you how many answers you're gonna have.
Oh, why didn't you just, why can't you plug in a number like after you did 2?
Why did I do, what was that?
Why can't you just, do the factoring after you did 2?
I'm at x to the 3rd.
Oh,
And factoring, the methods, most of our factoring methods start with x squared, right? I could have on this one because I know it works, but it's best to just be in the habit of bringing down to x squared.
okay.
I think you're using x to the 6.
In the x to the 6, you're gonna have to take it down and find 4 numbers that work.
Why can't you just bring it down to a graph by group?
You could, but it isn't always gonna work. Now we've been doing nice ones.
Show some x's.
I mean, because x to the 6 could get more answers, right? But what also could give you a lot more work is, let's say my last number is 72 and my first number is 24. Factors of 72 and factors of 24, you're going to have about 60 to 80 options.
But that's so cool. Are we gonna run into that?
Yeah.
Oh,
I am so gonna skip those.
What if it was like x
The other
is
problem I
6
would skip.
and then your p was like 1?
1/1. It might be a multiple. Keep trying one.
So if it'll be like
Okay. On this page, we did not get through everything on 3-4. We'll finish it up tomorrow. You should be working. This is on page 347. Let me look here. I wrote down is 3 through 48 by 3s. You probably can't do discardies yet, so you probably can't get up to those. So don't worry about that far. So let's go 3 through. Let's go 3 through 33 by 3s. What looks like a fun one
Multator wheel.
There's a 5.
to do. 347.
What is 5?
It's the page.
What ones do you wanna add in?
He's working on it. It was like 7.
They don't give me any large ones here.
We need a lot of points. Give us a
7 and
grade
21.
booster. All of
Yeah,
them.
grade booster.
Three, we want number 3.
We want
Grade
3,
booster.
6, 9, 12, 15, 18, 20, 24.
Should we try 50?
No. Wait, you said we had to do.
I mean, I'll just throw it on there. 50. Do the 50 up the way we did it so far.
We like to
50.
50? What is it?
50. Let's just do the 50.
10 and 50?
just 50.
Just 50 up to the way we've done it?
Yeah.
Find
out all the zeros. And then we'll solve some more shortcuts tomorrow.
what's the exponent on it?
5.
Gonna be my card. Oh, pretty good.
Oh, 4. Actually, 4.
Oh, 4. Let's just take that.
52. I was looking for an extra 6. I don't have any.
Just a regular.
Uh,
Which card? Your card. I quit.